Okay, welcome back. We're on page 87 talking about these memory interrupt and DMA. So an interrupt request, an IRQ. Let's see if we have an IRQ in here. We do. We have an IRQ. So interrupts are hardware-based alerts. In other words, this device needs to tell the operating system, I've got a byte. Let's talk about something simple. A serial port, okay? A byte shows up at the serial port. Well, it has to say, hey, dude, I just got a byte. What would you like to do? So it has to send an alert. So it's assigned an IRQ to the operating system, and the operating system says, oh, I just got an alert from a serial device that a byte is ready. Let me go get that byte. So that's how they talk between each other. You know, some devices, they talk nonstop, but a serial port, unless you're sending data, it's not talking, right? It's not sending anything, right? So only when, the letter A appears on your keyboard does it actually say, oh, I need to do something, right? So an interrupt. Memory range. So complex devices like video drivers typically have huge chunks of memory in order to speed up in performance, but you wouldn't expect that, for example, on a keyboard. For example, if I go down here on the keyboard and go to Properties and Resources, I probably won't see DMA. Okay, all I see is an I/O port and an interrupt request. Okay, so memory is about if I map physical memory so that both the device and the operating system can share that memory. Now, listen to those words. Sharing memory between two hardware devices through this bridge called a device driver, okay? Does that sound a little scary from a security perspective? Yeah, that's why we had to go for signed device drivers. You can't just have somebody go in there, because that means all they could do, lots of strange things, if they could get to shared memory. Okay, DMA, direct memory access. This is a weird one. So in a high performance, let's use a graphics card as an example. Instead of asking for memory and having it go through the CPU, or memory request, goes to the CPU goes, gets the memory, takes the memory, and then sends it back to the device. There's a thing called direct memory access, DMA. So that it's configured so that the graphics card can talk directly to the RAM on your machine without having to mess with the CPU. Now, this makes very efficient. And if you really want fast, frame rates in your game, well, then DMA is clearly the way to go. You don't want to bottleneck your device driver by having to ask Mother May I for a chunk of memory. Okay? That's kind of how the way that works. Okay, so typically you don't have more than one device that shares those things, right? In other words, every one of these things are kind of separate. You don't share memory between a keyboard and a mouse. You don't share interrupt between a keyboard and a mouse. You don't share, memory or any of those things, right? So each device, now in the old days, this was problematic because first of all, there weren't that many interrupts. There was like, a dozen or so. And so, man, you were limited on how many devices you could plug in. And then, well, this device was supposed to interrupt number 5, but this one wants to interrupt number 5 too. And you had to go in there and manually change. Now, plug and play has solved that problem. It basically says, hey, I'm a device, and the machine says, hang on a second. Okay, I'll give you this one, this one, this one. Is this okay? And the machine says, sure, that works for me. And we're done. Okay. Driver signing. So one more time, I'm going to go to driver details. Okay. And, driver. And driver details. And it's going to tell me that this is, provided by, and digital signer is Microsoft Windows. This is cool. Now, I don't think I'm going to have, because this is a virtual machine, I don't think I'm going to have any other ones other than Microsoft ones. Actually, well, this one doesn't load, but maybe it shows up. I don't know. No, it still says Microsoft. Okay. So the point here is that if you want to play the game and you're a vendor, then you either need to sign your own device drivers through a rigorous testing program, or Microsoft could allow you to submit it to them and store them on their server. Now, HP, for example, has a very minimal printer interface that that they're given to Microsoft, and Microsoft signs it and it's theirs. Okay. But they also have their own. Same thing with like NVIDIA. If I install a $5,000 NVIDIA graphics card, Windows is going to say, well, I'm going to use my generic one that NVIDIA gave me like 2 years ago. It's good enough to get things going. But you're going to have to go in and say, aha, I want a better one. So there's 2 device drivers, probably one signed by Microsoft living on Microsoft servers, and then a signed one by NVIDIA living on an NVIDIA server that you're going to have to go do something on. Okay, cool. All right. So next on page 90 is, by the way, I have a code signing certificate. I'm a developer. And so whenever I write applications, I go in and digitally sign my software. I mean, I don't write device drivers, but that's not really the point. The point is I had to apply for and get a digital signature. Now, there's 2 things digital signatures can tell you. One is, without a doubt, you know who it came from. It came from Microsoft, came from NVIDIA, or it came from me. No doubt about where it came from. And secondly, no one has messed with it since you created it. In other words, no one's added a byte, changed a byte, done anything to it. So it's the original source and then integrity. And those are the 2 things that digital signature can provide for you. Okay, now let's move on to page 90. So we're talking about the registry and services. So in the old days, applications kept their stuff in what's called an INI file, just a text file. Okay, there are some applications out there that still do that. For example, I'm writing an application in a particular flavor of Python, and it still uses INI files for configuration. Like, okay, whatever. I mean, they're not gone. They're just practically gone from Microsoft world. Anyway, they were stored everywhere. Every application had their own. So back in the day, you can install Microsoft Excel or Microsoft Word. It wasn't necessarily like a suite of applications. And so each one had its own little INI file. So if you change the printer settings in Excel, you were not expecting those printer settings to change in Microsoft Access. Not at all, because they were completely separate. And plus, there were text files and people were clumsy, and they were written in locations where the poor hapless human had access to them and could edit them. Like, oh man, whenever you give the poor hapless user access to fiddle with stuff, they're going to fiddle and they're going to screw it up. So we had to come up with a better way of doing this. So we created this hierarchical database called the Registry. And that's where these things are stored now. They're not stored in INI files. Okay, so let's, on page 103, they talk about, the registry editor. By the way, the registry editor, I'm going to close some of this stuff down. Okay, the registry editor is a very common thing, and I would think, for example, sure, it's going to be here. It's a very common thing. No. So I'm going to type registry editor, and then once again, do I have this thing pinned? No, I do not. Well, I do now. Okay. So this is a common thing, and if you're in the administrative world, you probably ought to go ahead and do this. Go ahead, because you're going to be using this thing a lot. So, what the heck, right? All right. Registry editor. Now, these are the top level thing called hives. Let me explain what this thing means. A hive is analogous to a drive letter in the file system world. So classes root stores information on all installed applications and their extensions. In other words, if you see a .docx, this is the database that says, I see a DOX, what do you want me to do? It looks under HKey classes roots, finds out that the associated application with that is called Microsoft Word, and then it evokes the Microsoft Word. That's how that mapping between file name extensions and applications work. You've probably seen this before, like particularly in the browser wars about who gets to be your default browser. Current users, this is the stuff that you have good permission. Now, by the way, it's fairly obvious, I would think, that you probably do not have permissions on HKey classes root. That would take administrator rights. But HKey current user, this is stuff about you. Now, you have changed your background. You have changed the timeout for the screen blanking. You have made lots of changes, right? So that's you and only you. No one else has those changes. So this is where those settings are staying. Local machine is talking about the local computer. This is where the device drivers are. The enumeration of the device drivers. This is a perfect place. This is where it says, here's where all these things are. Users is all of the logged on users. Now, in our case, we're only going to have one because we're not actually having two people logged on at the same time. So you probably would only have access to a tiny piece of this, right? The one that belongs to you. The rest of them you would not. And then current configuration. Now, this is the strange one. The local machine and current configuration are kind of sort of synonymous. This was like permanent, and this is about what happens when I boot my machine up. In other words, for example, this contains, well, let's think of a good example. The date and time zone, okay? So current configuration, when I boot my machine up, it's going to say, aha, I'm a member of this domain, or I'm a member of this work group. Here's my machine name. Here's what time zone I'm in. All the things that are relevant to the running of the machine when it starts up. So they don't go in and modify this. This is, I'm relatively read-only. It's not, but you know what I'm talking about. Things rarely change in that. But this, every time you boot the machine up, this gets wiped and replaced with a new set. Okay, cool. Let's continue. All right. So I'm going to go to my users guy and click on here. And if you've got things configured the way I ask you to, you're going to see this thing called ntuser.dat. That is the portion of the registry hive for the current user. That is the file. Now, you can't open it or anything. You can only open it inside the registry editor, but that's where it lives. And so the other ones live in another location, but we're not going to worry about that for the right time. Okay, so if I need to configure something that's only to me, well, then that's where that's going to be. All right, so let's do some poking around. Let's see if we can find out. Remember we talked about where the local machine and things so where would the machine name, for example, be? That's relatively permanent. I mean, it doesn't change very often. So let's just go poke through. So where would you think it would be? Hardware? I mean, maybe. But it's not really hardware, is it, right? It's a name of the machine. So either software or system. What do you think? What do you think? Let's try system. And oh my goodness. Now, there's a thing called control set. So if your machine doesn't boot, or you booted in safe mode, you get control set 1 and control set 2. And the current control set is whichever one you're currently running. Okay, so it's very possible, there are other people who have different setups. For example, if I'm a developer and I'm writing a device driver, I'm going to create another boot scenario. When I boot my machine up, it's going to ask me, do you want to boot normally, or you want to boot in the driver debug mode, the kernel debug mode? Now, normally you would never do that in the real world, but this is how it would tell the difference. So it's going to be current control set. That's the one that I'm interested in. And then it's like, oh man, control enum. Ooh, here, enum. This is about devices. Yeah. So here's the PCI device, and here's the USB device, but that's not what we're after, obviously. Okay, so current control set. So I'm going to go for control. That sounds a little weird, but control means, okay, what we're actually doing here. All right. So where in the heck am I going to find the machine name? What do you think? Is it a Windows thing? I would certainly think it's a Windows thing. Is there one in here that makes some sense? Oh, computer name. Let's bring that guy up. And then it says the active computer name, because you remember now, when you change the name of a machine, it kind of lives in two worlds at the same time. Like you rename the computer and it comes up and says, you need to reboot to continue. So this is like the before and the after, okay? But this is the real one. So this is the computer name for the guy. Okay, once again, we're coming up on the 15-minute mark. You guys know how this works.